Hello! Yesterday we learned about multiplication properties of exponents, and today our learning target is I can use division properties of exponents to simplify and evaluate expressions. Please take a couple of minutes, hit pause, and do the two warm-up questions. The first one, you had to multiply 2 times 3, you get x to the 6th power. Number 2, this was like what we learned from 7-1. You have 1 over 2 cubed, which is 1 over 2 times 2 times 2, which will be 8. 1/8 is your answer. Number 3, it's all over 1. You have to bring your x to the negative 1 down, and you get 3 squared over x, which is simply 9 over x. And number 4, you have to distribute, and you get v, negative 2 times negative 4 is positive 8. W to the negative 12, but you're still not simplified, so all of this is over 1. You have to bring your W to the negative 12 down. You get V to the 8th over W to the positive 12. Well, today we are going to look at some repeated multiplication to see if we can find out the answers. If I do 2 to the 7th, we know that's 2 times 2 times 2 times 2 times 2 times 2 times 2. Over 2 to the 4th, we have 1, 2, 3, 4 2's. Well, just like division, when you have multiplication, this is all one giant multiplication, there's no addition or subtraction, it's all one term, you can cancel. And you're left with 2 times 2 times 2, which is 2 cubed. So we want to see if we can get from here to here. And I bet you are noticing it. What happens when you divide like powers? Well, in your glasses, notice you would subtract your exponents. Isn't 7 minus 3, you would do top minus your bottom. 7 minus 3 gave us, 7 minus 4 gave us an answer of 3. So your quotient of powers property, hit pause and take a second and write this down. When you divide like bases, it is very important that they are like bases. They are the same base. You subtract their exponents. You would do top minus bottom. So if you have a to the m over a to the n, you do a to the m minus n. Let's do a couple examples of this. If I have a to the 8th over a cubed, my like base is a to the 8 minus 3, so you get a to the 5th power. Number 2, our like base is x, so you would have x to the negative 3 minus a negative 5, which becomes plus positive, so you get x squared. Number 3, notice we have our like bases. You can think about it like two different parts. You have two different subtractions you're going to have to do. I'm even going to take a second, and I know that there's multiplication in between here. I'm going to draw a little barrier. So if I look at the left base of b, I have b to the 5 minus 3 times my little barriers right there, c to the 9 minus 2, which gives me b squared times c to the 7th. The last one, number 4, and you're going to need to add this to your note sheet, please, or actually it's on the second page. It's on the back page of your notes. We have to do something first. Notice I don't have this simplified yet. Each, my a, b, and c, they all have an exponent of 1. So before I can divide, I first have to raise it to the power of 3. So my numerator stays a to the 4th, b cubed, c to the negative 5th, over a cubed, b cubed, c cubed. Now I'm going to do the same thing. My like bases, they're all arranged. So I would do a to the 4 minus 3 times b to the 3 minus 3 times c to the negative 5 minus 3. When I do my subtraction, 4 minus 3 is 1, a to the 1st, b to the 3 minus 3 is 0 times b to the 0 times c to the negative 8th. We're not simplified yet. Remember, we have to simplify completely. Well, all of this is over 1. b to the 0 just equals 1. And a to the first we can just write as a. We don't need to write the times 1 over c to the negative 8th has to go to the denominator and become c to the 8th. Now we're going to use repeated multiplication one more time. If I want to repeat this, I would have 2 thirds times 2 thirds times 2 thirds. We're not going to actually do the multiplication. Nothing can cancel. But if I were to write the numerator as a power, I have 2 cubed over 3 cubed. Well, how could I get from here to here? Oh, each of these have an exponent of 1, just like with your multiplication. Now only you raise it to the top and to the bottom. So your quotient, or your power of a quotient, states when a quotient or a fraction is raised to an exponent, the numerator and the denominator are each raised to that power individually. Take a second, hit pause, and please write that down. So let's just do it. Number 5, we have 2 to the negative third, 2 fifths to the negative third. So if we raised each, the numerator and the denominator, to it, we'd have 2 to the negative third over 5 to the negative third, but they each are in a different spot. They both have negative exponents, so that has to go in the denominator, and the 5 cubed has to go in the numerator to become positive. So we end up with 5 cubed over 2 cubed, which that simplifies to 125 over 8. I have a trick for you. Your trick is when a fraction is raised to a negative exponent, flip the fraction and make the exponent positive. Let me show you what that would have looked like. If you had 2 fifths to the negative third, you could flip your fraction, 5 over 2 to the positive third, and you get 5 cubed. These each have a new exponent of 1 over 2 cubed. Aha, it's the same thing, 125 over 8. Either way, in the yellow or in the white, they end up with the same answer. You can do it either way. Hit pause. I'm going to erase this and go on to number 6. Number 6, this time, it's your entire numerator raised to that second power. So you have to raise all parts to the second power. 3x, they both have exponents of 1. You need to take the square to 3 different exponents now. So you have 3 to the 1 times 2 is 2, times x to the 1 times 2 is 2, over y to the 3 times 2 is 6. So 3 squared is 9x squared over y to the 6th. And you can't simplify it any further. Number 7, anybody remember the trick? I'm going to use the trick, and I'm going to go ahead and right from the beginning, I have this negative exponent. I'm going to flip the fraction. You don't have to, but I just think that's easier. Get rid of that negative exponent. So now we have 3 a to the negative third, b to the 4th, over 4a squared, b cubed, all positive squared now. Notice, nothing changed with exponents. inside. All you literally did, it's like you cut it in half, and you took this whole thing and moved the whole thing down. This whole thing and moved the whole thing up. Nothing changed. Now, you could do this a couple of different ways. I'm going to first divide because I see these in here. And I'm going to say, well, this is 3 times, 3 times. They have their like bases. So I'm going to leave it as 3/4, because they're not like bases, times a to the negative 3 minus 2 times b to the 4 minus 3, all quantities squared. So let's take it to the next step. We still have 3/4. A, negative 3 minus 2 is negative 5. B to the first, all quantities squared. Now, I'm going to write them. I'm going to simplify inside here. And my a to the negative 5th is really over 1. So he has to go to the denominator. And b to the first is in the numerator. So when I simplify that, my numerator still has the 3 in it, and my b to the first. But my a to the 5th went down to the denominator. So my denominator had 4a to the positive 5th, and our 1 and 1 is really just times 1, the whole thing squared. So now we can distribute our 2. Remember, 3 has an exponent of 1 and 4 has an exponent of 1, so we have to distribute it 1, 2, 3, 4 different spots. So I'm going to get 3 squared times b squared over 4 squared times a to the 2 times 5 is 10. And simplify further, 9b squared over 16a to the 10. And there's a variety of ways that you could have done this. This is just one simple way. The last thing we're going to talk about is scientific notation division. The first thing that you're going to do whenever you have scientific notation is write as a fraction. So you'd have 4.6 times 10 to the negative 4th over 2.3 times 10 to the negative 2nd. Then write as a product of fractions. So you have 4.6 over 2.3 times 10 to the negative 4th over 10 to the negative 2nd. Number 3, simplify both fractions. Well, 4.6 divided by 2.3 is going to give you 2 times 10 to the negative 4 minus 2, you get 2 times 10 to the negative 6. Last but not least, you have to put it into scientific notation. So this is in scientific notation, so you're good to go. But number 9, when you do number 9, you have 3.8 times 10 cubed over 7.6 times 10 to the 5th. Then you separate them. 3.8 over 7.6 times 10 cubed over 10 to the 5th. When you do your division, you end up with 0.5 times 10 to the negative 2nd. You cannot leave something as 0.5. That's not in scientific notation. This as a decimal is going to be 0.5. Move it 2 places to the right. So you get 0.005. If I look at 0.005 and I want to put that in scientific notation, I go 1, 2, 3. So the answer is 5 times 10 to the negative 3rd. You have to put it into scientific notation. You can now start your 7-4 homework worksheet.